Hello and welcome once again. In this module, we are continuing the discussion of meta-programming non-standard evaluation. Here, we will let you know how to create an environment and how to evaluate an expression under this environment. We will also show you how to create two environments simultaneously, one being the parent of the other. So, here we will tell you how to use the elements of both the environments and how to evaluate expressions under these two environments. So let's see what is there in the discussion with lots and lots of examples which will help you to know this topic more vividly. So let's see what is there. In this module, we are continuing the discussion that we initiated in the previous module. In the previous module, we considered only one environment at a time. But here, let's see what will happen if we consider two or even more environments simultaneously. So, the thing is how to create two environments at a time. Let's consider this thing for two. Then we will move ahead with more than two environments later on. For two environments, we are considering that one is a parent of the other. So let's see how to evaluate the expression in this example. Here, at first we are defining environment 1 as a new environment, and then the value of x is defined to be 1 in it. Then environment 2 is defined considering environment 1 to be the parent. Now, as in environment 2, environment 1 is the parent. So, environment 2 can take the value of x, which is defined in environment 1. Only here in environment 2, the value of y is defined to be 2 additionally. So, now we have two environments, environment 1 and environment 2, and now the question is how do they act? Here, as one can see, environment 1 is the parent of environment 2 and global environment is the parent of environment 1. So, this means that when eval function evaluates an expression in the context of environment 2, it will go to environment 1 and then global environment, package environments and base environment. Now we evaluate a simple arithmetic expression containing symbols in these two environments. Here we are assigning quote of x plus y in expression. So if we type eval, then within first bracket expression comma environment 1, it will show an error, and the error is exactly the same which were shown previously. So we should evaluate in the environment where y is properly defined because the error contains object y is not found. We know that y is defined in environment 2, so we are evaluating it in environment 2. And the final answer is 3, which we can get by using this expression, that is evaluation, then within first bracket expression comma environment 2, because in environment 2 the value of y is specified. So this will be like the one we have given here. Now consider another simple example on three environments. Here, environment 1 is the new environment where x is assigned to be 4. Then, considering environment 1 to be the parent, environment 2 is defined with y as 2. And finally, to add the next one, that is environment 3, here we are using environment 2 as the parent and z to be 3. So here is the code through which we can assign the values of x, y and z, and we can assign the environments as well. Now, if we want to evaluate the expression x into y into z, then we need to write the expression and insert it within the eval function. Now, the question is why environment 3? Because environment 3 is encapsulated within the other environments. So, it contains all the values of x, y, and z. So, here is the output, which reads that the final value after the multiplication of the 3, that is x into y into z, is 24. So, what if we consider the exactly same expression but in environment 2? In that case, it would only have the values of x and y, and z is not there. So, the expression will not find any value corresponding to z to evaluate. So, let's write x into y into z within quote and put it within expr, that is expression. Then we are putting expression and environment 3 within the eval function, and finally we are having the output as 24. In fact, the eval function, that is eval within bracket expression comma environment comma enclose, basically follows some of the logics to evaluate a quoted expression, and the logics will be like: if env is an environment, then evaluate expr in environment by looking for symbols all the way along environment and its parent environments until found. If environment is a list, then evaluate expr, that is expression, given the symbols defined in the list. Whenever a symbol is not found in the list, the function will go to enclosed environment to find along the chain until found. Now, if a symbol is not found until the empty environment is reached, then we will say that an error will occur. Now, what do you mean by empty environment? Actually, it means the only environment which have no parent. Now, this logic sometimes show notable strange behaviors. Like, for example, let us consider this. Using these sets of codes, as it has been shown here, we can get the value as it is expected. Here, what we do is we are specifying a new environment in the name of environment 4, and then within the eval function we are specifying x is equal to 6 and the environment 4, and finally we have the following output. However, if we supply a named list of values to get the evaluation and specify environment 4 as the enclosing environment, then it does not work as we might expect. Now we are continuing the previous example and we are writing the code that is given. Now it is understandable because list within first bracket p is equal to 2 provides a set of symbols that are given values. If the symbols in expression are not defined in the list, then it should go to the enclosing environment and its parents to see if the symbol exists. Therefore, in this case, it does not happen in environment 4 at all. So, the actual thing is that only symbol lookup happens here. Now, the main feature of the non-standard evaluation is capturing expression. So, for this, let us consider the substitute function. So, how does this function work? Substitute makes non-standard evaluation possible. It looks at the function argument and instead of seeing the value, it sees the code that has been used to compute the value. So, here is the difference. So, this means it captures the expression only and does not help to evaluate the value of an expression. Now, if you observe closely, you may find that the substitute function is similar to the quote function, that is a function which we have already discussed in this module. So let's consider a simple example. Here, what we do is we are defining a function to be f, and we are defining it to be a function of x, and we are inserting substitute of x within this f function. Now, if you type f of x plus y square plus 4z, it will give you exactly the expression x plus y square plus 4z. Similarly, if you write f of 4 plus 4, that will give you 4 plus 4. But when we write some expression after substitute, it returns the value of the function instead of returning the expression. Now here, getting the value is important instead of getting the expression. So let's see how to get the values. So continue taking the previous example. Here, what we do is we are defining f to be a function of x, exactly what we have done previously, and within the function we are inserting substitute of x. Then after this substitute function, if we write down x, then actually the function is completed. And then only if we type f of 4 plus 4, then it will give us 8, that is our desired value of 4 plus 4. Now just remember, if we write the expression before substitute, then it will return the expression only instead of evaluating the value of the function. And hence our objective was not fulfilled in that case, because primarily our objective was to get the values, not the expression, because expression is something which we are already giving. Now again, consider the example which we had gone through a little while ago. Here, what we are doing is that we are defining f to be a function of x, then we are writing down x plus 2 within the function, and then after x plus 2 we are writing substitute of x, and then we are closing the bracket of the function. Now, if we type f of 4 plus 4, then again it will give us the expression 4 plus 4. Now the thing is clear to us, as we know from the previous discussion. Here also x plus 2 is not written after substitute, instead it has been written before this, so we are getting the expression, not the value of the expression. So the example is exactly the same with that of the previous. For now, we won't worry about exactly what the substitute function returns, that is the mechanism behind it or how it works. Actually, this is the topic which we will discuss in the following module. Now, here comes the idea of the departs function. So again the question is where the function will work. Actually, this substitute function is used with the departs function. So the question is, what is the departs function? Departs function is similar with substitute function. That means it also gives an expression and it turns the expression into a character vector. For this, let us consider this example. Here, g is a function of x containing departs of substitute of x. So here is our g. Now the question is, what does the function return? The function will return the expression that we have got using the substitute function. We are showing the output here. If we type g of 4 plus 4, then it will return us 4 plus 4. Again, by writing g of x plus y square plus 3 into z, we are exactly giving what we have given here. That is the expression x plus y square plus 3 into z. So the expression is similar to that of substitute. Now, there are a lot of functions in base R that use these ideas. Some use them to avoid quotes. Other functions like plot.default use them to provide default labels. Now, data.frame also uses the similar idea. If you build a data frame containing x and y with x containing the numeric values 1 to 4, whereas y contains the first 4 letters, that is, our x will be like the one we have given here, and y will be letters 1 to 4, that is A, B, C, and D, and hence our data frame will be constructed with x and y. Now, in this module, we have learned some of the aspects of metaprogramming, and in the next module, we are going to learn the use of subset function and many more. Subset is particularly useful application of non-standard evaluation and is broadly used as well. So let's stop here and try to understand the things that we have discussed in this present module. So in the last two modules, we had some basic elements of metaprogramming non-standard evaluation. We came to know what actually the mechanism behind this metaprogramming is, and with the examples, these mechanisms came alive before us. So this is what metaprogramming actually is. We also discussed about eval function, substitute function, the syntax of these, some examples, and many more in this module. So we are stopping the discussion of metaprogramming non-standard evaluation here, and from the next module onwards, we will come to know what subsetting actually is. So let's stop here and let's concentrate on the next module.